Okay, so we want to find the area by integration. And we have two options. We can integrate with respect to x, or we can integrate with respect to y. Okay? Before we do any of that, we want to be able to express this as a function and this as a function. So we're going to let this be y equals f of x. We're going to let this be the graph of y equals g of x. Okay? Then it should be clear that the area could be expressed as the integral from 0 to 4 of f of x dx, right? And that would take care of this much of the area, okay? Plus the integral from 4 to 6 of f of x minus g of x. Right? Okay, so that's one way. All you got to do is find f of x and find g of x. And that's very easy. Okay? We'll do that. But the other way is then, or we can do the integral from 0 to 4 of y, right? So we want to have inverse function, and we need to do g because it's to the right. Okay? Well, that's kind of what we want, but I really don't want to quite write it that way, because if you do the inverse of g of x, then it's a function of x, not y. And if I make that x a y, that would technically be right, but it would be confusing. Okay? So that's the idea, and that's good if you can keep the notation straight. But I'm going to kind of put an x through that and say, well, okay, let's go ahead and express this and this as functions of y. Okay? And call it h of y and x equals k of y. Okay? We could express either of these as a function of x or as a function of y. Okay, well, let's get the function of x first, because once we have that, we can actually pretty easily find the function of y. Okay? And we are essentially doing an inverse function, which is kind of why I wrote that down first. So we're going to cross that out. We're going to say, no, the area is going to be the integral from 0 to 4 of k of y minus h of y with respect to y. Okay? Okay, well, what's f of x? What's g of x?